All right, let's look at this challenging problem, number 10 in section 2.4. Um, it's not really that difficult, but understanding what's going on can be a little confusing for students. We have a piecewise defined function here. It's defined for all real numbers. And then there's this c involved in the formula, and we're to find the value of c. So c is some real number that makes this function continuous. Okay. So first of all, the function is clearly continuous for any value other than x equals 6, because for values less than 6, it's just x squared minus some constant, c, maybe c is 2, x squared minus 2. That's just the parabola shifted 2 units down. A parabola is continuous on its domain, certainly continuous for all values less than 6, so it's continuous there. For values greater than or equal to 6, it's just 7x plus 3 times whatever c is, just some constant. This is a linear function, a line of slope 7. So lines are continuous everywhere in their domain, and certainly continuous for values greater than 6. So the question is right at 6, what's going on? So first of all, what's the value of the function at 6, f of 6? Which formula do I use? Well, notice x is greater than or equal to 6. We use the bottom one. So f of 6, I replace x with 6, and I get 42 plus 3c. So whatever c is, right, I'll be able to know exactly what f of 6 is, but that's what it is. So our goal is now we want to have the limit as x approaches 6 of the function f of x to be equal to f of 6. That will make it continuous, right? The limit exists, the value of the function exists, and they're equal. So what is the limit as x approaches 6? Well, let's look at the limit from the left and right, since we've got expressions below from the left and above from the right of 6. So what's the limit as we approach 6 from the positive side from the right? Well, if 6 is from the positive side, we're plugging in values greater than or equal to 6, right? So the limit as x approaches 6 from the positive side of the function would be limit as x approaches 6 of 7x plus 3c, right? And I can find this limit by plugging in directly, because this is, as I said, is a linear function, continuous. Plug it in, I get 42 plus 3c. Well, that's good, because that's equal to the value of the function at 6. But this is just the limit from the right. Okay. The limit from the left, as we approach 6 from the negative side now, what's that going to be? Well, if we're approaching 6 from the negative side below, we have to use this formula, x squared minus c, right? So I'm going to take the limit as x approaches 6 from the negative side of x squared minus c, and this is plugging in 6 squared minus c, or 36 minus c. Well, 36 minus c, is that equal to 42 plus 3c? Well, we need it to be, right? So we're going to do that here in a minute algebraically, but graphically what we have so far now is, right, as we approach 6 from the positive side, we're on a 7x plus 3c is a linear function, and we're getting closer and closer to what? To this point, whatever it is, right? This value is equal to the value of the function, right? So we are actually right continuous. We are right continuous, right? The limit from the left, though, right now is some value. It's the 36 minus c. We need to find the value of c that makes these two values the same. In other words, geometrically, we want to bring this hole and connect it into that socket, if you will, or bring this point and connect it into that hole, right? Bring it down. As we adjust c, right, the graph of x squared minus c will shift up and down, and as we adjust c, right, this basically is the y-intercept. We'll make this line shift up or down as well. So we need to sort of bring them together to make that connection, right? We don't want to jump discontinuity here. Okay, so that's geometrically what's going on. So algebraically, it's pretty easy. I just need this limit here from the negative side to equal the 42 plus 3c, right? And that will connect the two pieces. So I subtract 36 from 42, giving me 6. Subtract 36 from both sides. Subtract 3c from both sides. So negative c minus 3c is negative 4c. Divide 6 by negative 4, and we get c is negative 3/2. That's the value that will work. And you can see if c is negative 3/2, 36 minus a negative 3/2 is the same thing as 42 plus 3 times a negative 3/2. You can actually compute that and see that's the same. Okay. All right. So it's a little tricky on these, but that's the idea. We want to make sure that both to make sure it's continuous, we want to make sure the limit of the function at 6 is equal to the value of the function at 6. Okay, if you've got questions still, let me know.